Yeah, hi everyone. I wanted to share an update on some things I've been working on with Dagger and AI modules, and in particular with Zenith. So please jump in any point and ask questions. Happy to do that. I wanted to start by just answering the question, well, what is Zenith, for anyone who isn't familiar with that? I know we have, I think, Solomon and Sam here on the call, so if you want to jump in and give me a better definition of Zenith than this, then please do. But my interpretation of Project Zenith is really this idea of making Dagger modules that are self-contained and isolated, that become these kind of reusable components that can reference other modules, and the goal here is to create an ecosystem of these components that can interact with each other, these modules. So you might then ask, well, okay, so that sounds cool, but like, what do you mean by Zenith Does AI? And so in particular, I've implemented a new Zenith module called the Helix Module that triggers, at the moment, the Stable Diffusion XL. For people who aren't familiar with Stable Diffusion, it's a generative image model. So you can give it a text prompt and it will generate an image based on that text prompt using some clever neural network magic. And it requires a GPU, which is interesting because Dagger only recently added GPU support, and I'm really glad that Dagger did because it enables more interesting use cases like this. The other thing about this Zenith module that I wrote is that it runs an in-container GPU scheduler that I built called Helix, and that thing is there to efficiently pack multiple models onto the same GPU. You might be familiar with the idea that there's a bit of a GPU shortage at the moment. It's quite hard to get GPUs and they're quite expensive. And so it's quite useful to be able to pack lots of models on the same GPU where they fit. And you can do that because, for example, Mistral, which is a large language model, uses about 7 gigabytes of GPU memory. Stable Diffusion, I think it runs in about 6. And so if you've got a 24 gig or a 40 gig or an 80 gig GPU, then you can actually pack quite a lot of those in. Also, if you're doing fine-tuning, which I won't demo today, but I hope to be able to demo in the future with Dagger, and in fact, I previously did just with plain Dagger, but without Zenith, then you can get these fine-tuning jobs that run on the same GPUs and pack those in amongst the inference jobs. So anyway, so this is the architecture of the Zenith module that I built. The Helix module. What we have at the bottom is the command that the user runs. So that's Dagger download, and then it references the module, the Helix ML runner, and then it calls a method on that module called generate file, which download is a built-in command that expects a method on the module which returns a file object, and that it also passes a string parameter to that which says colorful elephant, because hey, we want a picture of a colorful elephant. So what that does is, well, actually, I'll show you the demo first, and then I'll go through kind of exactly how it works. Yeah, so what we've got here is a shell, which I'll make a bit bigger so everyone can see it. And we can run that very command that I just ran. So I'm going to ask for a bit of audience participation. Would anyone like to shout out the name of an animal, their favorite animal, or any animal, just to prove that it's live?
An okapi.
Oh my goodness, how do you spell okapi? You made that hard for me.
O-K-A-P-I.
Oh, that's quite a nice thing. I'm going to learn, hopefully, what an okapi looks like. So what this is doing is it's booting up that Dagger module. Actually, I'll make it a bit smaller because something you can see here is, in a second, you should be able to see the output from the module as it's running, which, there we go. You can see the progress of the image generation. So that's output that's being streamed from the model as it's running, and then it's exporting the asset to dot, and then we can see, hopefully, That's interesting. Oh, there it is. Way, is that anything like an okapi?
Yeah, not. I mean, not that it's like a small forest giraffe almost.
Awesome. Okay, so it worked. It worked despite my my SFTP link to my server making my Mac freak out a bit. Cool. So that's an example of Zenith generating an image using generative AI. I'll now walk you through kind of. Oh yeah, I got applause. That's really nice. Thanks. So I'll walk you through what happened. So what just happened? What just happened is that we ran this command to download this file. That command got translated into a call into the Helix Dagger module, which internally made a call into the Helix client, which is a command line process that's running inside a container inside the Dagger module. The nice thing about Dagger modules is this idea that you can encapsulate complexity inside the module. So like the user didn't have to know about the fact that there's actually a client-server architecture going on inside this thing. But that's all happening kind of under the hood. That the client then made a REST call to the runner API, and the runner is running inside here as a service, which I'll talk about in a bit more detail in a sec. And then that runner process that's running as a service, which is exposing a REST API, then booted up the SDXL model. It had the AI model weights baked into that container image. It then ran the inference against that SDXL model. It then turned around and sent the response back to the Helix client as the API response as a base64 encoded string of the PNG file. And then the Helix client returns the pointer to the file back as the output of the module, back to the Dagger client. So there's kind of multiple layers of clients and APIs going on here, but it's all kind of nicely abstracted for the user. And I'll also show you the code. Hopefully it's legible on your screens. Once I figured out how to get this working, it turned out to not be that much code, and I actually think it's quite nice code. It's quite, as in the Dagger API is quite nice to work with because it's pretty clean. So what we see here is that we define this service inside the Zenith main.go file. And that says, give me a container from the Helix image, give me GPUs, this is your entry point, and then expose the port of the API server, and then expose this as a service. And then the generate file method, which is the one that this thing calls, generate file, it says, hey, give me a generate container, and then do some stuff which I trimmed out because it wasn't that important. And then return container.file of the path to the file inside the client container. And then, what does the client do? Well, what does this generate method do? Well, it says, hey, I'm going to need the Helix runner, which is the service. So make sure that one of these things is running. The way I think about it is like it's kind of running on the same Docker network almost, although I know it's not actually running inside Docker. But conceptually, it's like it's a lot like Docker networking. So it's like, give me access to this service on this exposed port, and then the client is saying, hey, I need to bind to that Helix runner service, and then I bust the cache so that I get a new result every time. And then I say, run this client, and you can't quite see the text that rolled off the end here, but it's like run the client with the prompt, which in this case was colorful elephant. And that's how it all works. So that's cool. Hopefully people will find it useful. I'm also interested in working on adding a large language model as well as a generative image model to this stack. And then people can do interesting things like asking an LLM to generate some code for them dynamically in their DAG and do interesting things like that. I wanted to talk a little bit about some interesting challenges I had while implementing the Zenith model, the Zenith module, because I always think that's interesting from a developer experience perspective, and on these community calls to kind of share some of the challenges as well as the successes. So my biggest challenge that I had around here was around sharing storage between these different components. Basically, in regular Dagger, which is what I had become used to when I'd done the other previous demos, I was able to bind mount things. So I could bind mount like a folder on the host into the container, and then anything that the container would write into that folder or directory would show up on the host. But they're not possible in Zenith, and that's by design. And if Solomon's still here, maybe we can talk a bit about why that is. Sorry? I think that was just a noise.
Yes, I'm here.
Oh, you're here. Awesome. Okay. Yeah, cool. Hi. Do you want to jump in?
I've been after. I'll let you go through the list.
Okay, cool. Awesome. Yeah. So yeah, the Zenith modules are isolated by design, which meant that I wasn't able to bind mount the directory from the host into the service that was generating the image. The other thing is that we've now got this client-server architecture, which actually we didn't have in my previous demos. So we actually have the need to share files twice here. The first requirement to share a file was because this thing is like writing this output.png thing, that file, right, which is the actual image that you want to get back to the user. So it started out that the runner was the thing which gets the file out of the image model, and then it was my first attempt to get the runner to share the file with the client so that the client could get it back to the user was to use a shared cache volume. And I don't know if it's meant to be possible, but I wasn't able to get it to work that the service was able to share a file system with the client container. So I updated the API so that it just returned the image as a base64 encoded string back to the client over HTTP, which is fine because it's all running on localhost, so it's not too slow, and you can stream things over REST, so that's okay. But that was one kind of hurdle I had with sharing storage, and then the other hurdle was, okay, well now I've got it. I've got the file in the client. How do I get it back to the user? And that was before I discovered this download command. So I was previously just running, I think, Dagger call, and then hoping to be able to bind mount a folder on the host back to the user. But that didn't work in Zenith. So I discovered this Dagger download built in, which is really nice because you just pass it back this like file type here, this one, and then it just works. It writes a file called output.png into the current directory, which is the desired behavior. And yeah, so I just kind of talked through these points on the slide, and once I figured out those bits, it was pretty straightforward. In terms of what's next, I'd quite like to get Mistral working inside a Dagger pipeline. I think there might be some interesting use cases for that. I want to bring fine-tuning back because I demoed fine-tuning previously, but it would be nice to have fine-tuning working with Zenith, because that's a use case that had some interest from the community, I think. And then I also had this kind of puzzle, which people on the call might be able to help me with, which is, okay, so one of the points of this client-server architecture and the whole reason that the runner runs as a service is because it would be really nice. The way these models work is that they take like 30 to 60 seconds when they start up. You might have noticed in the demo there was a bit where I was like, oh, it's going to start showing me the progress in a second, but it took took like 30 seconds. That was because the system was loading the model weights, which are a few gigabytes, like 7 gigabytes, I think. The language models are a bit bigger. Loading those weights from disk into GPU memory. And so it would be really nice if we could keep the runner container around across different invocations of clients, or if you have a DAG that's made up of multiple chained steps, and multiple of those steps want to access the same model and do inference. It would be nice if we didn't have to reload those model weights into GPU memory every time we made a new call into the runner. It would also be really nice if you could keep the model weights kind of in memory across invocations of Dagger. And I noticed that there was something in the documentation about services kind of having a grace period. So if you like call a service twice within 10 seconds or something, that it will reuse the same service instance, because they're designed for like long-running database processes and things. So it's a little bit like this use case. But then I also saw in the documentation that services are scoped to DAGs. So if you have two different DAGs that require a service, then they would end up with different instances of the service. So thereby defeating my attempt to like have long-running services that can get used by multiple DAGs. So that's an open question. I still don't know how to do that. So it'd be interesting to talk about that maybe. There's a little website here, and I've updated this with the latest command that you need to run. And like the steps are just install Dagger, export this environment variable, and then boom, it should work as long as you've got an NVIDIA GPU on Linux at the moment. And yeah, so that's it.